With IPv4 communication, we have unicast communication, multicast communication, anycast communication, and broadcast communication. With IPv6, which one of these just doesn't belong? Yeah, it's broadcast. We do not have broadcasting capabilities with IPv6, and that was done on purpose. Why? To improve the communication process. With IPv4, it was learned over time that broadcasting can hurt a network. Too much broadcast can hurt a network. So how do we eliminate broadcasts? Well, we convert those tools and services and features that relied on broadcast into using a more communication friendly option, and that is multicast. So a lot of the features that we've learned to love, like DHCP and ARP, with IPv4 used broadcasting. Well, now with DHCP and, well, there's no ARPing with IPv6. It's not called neighbor discovery instead. We use multicasting for more efficient communication. Because remember, broadcasting is essentially your device blurting out in the local area network, hey, does anybody have this? Or does anybody know that? And everybody receives that, and everybody has to process that information. Only the device that has the information you're looking for will respond back. Whereas with multicast, instead of blurting that information out to everybody, hey, does anybody have this? Or does anybody have that? In this case, with multicast, we say, I am sending this information to this dedicated address, and whoever's listening to it will receive it. If they're not listening to it, they won't receive it. So in this case here, we have our devices here that are listening, but this device down here, that one's not listening at all, meaning that it will not receive that particular frame or that particular packet that has been sent at all. So multicast is a type of communication, just like with IPv4, that is from one device to multiple devices that are listening for that type of information. If they're not listening for it, they're not going to receive it. So you can sort of see how that improves our methods that were used with IPv4. Whereas everything that needed to broadcast would broadcast, now we've modified the way that our services and features behave, and they can use multicasting to improve that communication process. Is it 100 times better? Does it make a huge world of difference? Well, I wouldn't say it's like night and day, but it definitely has improved the amount of information that flows around in an IPv6 network, because we don't have as much broadcasting that is going on now. We have more multicasting, but it's more efficient than broadcasting was. We still have our traditional unicast communication, meaning I have a very specific device I want to talk to. I have my source IPv6 address, I have my destination IPv6 address, and I talk directly with that device and nobody else. And then down at the bottom, we have Anycast. And for a lot of people, Anycast is a new concept because they never ever dealt with it with IPv4 because it was never talked about really. Now, if you were working with DNS, root servers, or any type of service or feature that you've deployed that requires some type of load distribution scenario, or you were using multicasting with rendezvous points with Anycast addressing with IPv4, then you'd be familiar with Anycast right now. But if not, let me tell you what it's all about. So Anycast is all about communicating to the nearest device that is offering you the service. The nearest device that is offering you the service. That's what Anycasting is all about. So let me give you an example of how we've used it with IPv4. So with IPv4, we have our DNS servers out on the internet. Well, the DNS servers, the top level DNS servers, are designed to really be used at some point in time to share all of the information in regards to host names to various devices. So what various other DNS servers? So here's what would occur. I have a PC that contacts a local DNS server. If the DNS server doesn't know the answer to the DNS question, then it's going to ask another DNS server who asks another DNS server. And so far, eventually, hopefully the top level DNS server knows the answer and can give it back. Now, with that in mind, would it make sense to have the top-level DNS servers all using the same IP address? You might say, well, no, because that causes a conflict. Well, not really, not really. So let's say you have a top-level DNS server in North America. You have one in South America. You have one in Europe. You have one in Asia. You have one in Australia. You have one in Africa. So you have these strategically placed throughout the world top-level DNS servers, all using the same IP address. Exact same IP address, but you've defined them as an Anycast address. So what happens now is that that specific address is going to be advertised into the internet. So all the internet-enabled routers, right, are going to learn about that IP address from many different ways, many different paths, many different portions of the world. And so what happens now is the router is going to do what? It's going to pick the one that is closest to itself and install that in the routing table. Why? Because that's what a router does, right? Using dynamic routing protocols. It says, I've learned about this address or this network from many different paths. Right? I can go that way, that way, that way, that way, or that way. So as a result of having all this information at my disposal, I'm going to pick the one that's closest to me. So the router automatically, no matter what, does that as a living. So the router already knows that, well, based on the information I received, this IP address is reachable over there. And that's the closest one. But does it get rid of the information about the other paths that can be used? No, not at all. So what happens is if this connection to that network ever goes down and it's no longer available, or the DNS server goes down, well, the router no longer has that information. So then the router says, what's the next best one I can go to? And then it would install that in its routing table. So it's up to the routers now. So we have a router right here as an example. And that router right now says the closest server is right here based on my routing table entry. So I'm going to go ahead and send the traffic there. Now, if that ever fails, no problem, because then the router would go over here instead. It would go to this one because that is the next closest one instead. So it's always going to send you to the nearest device that is offering that service. So the same thing could be true with network time protocol. With network time protocol, there could be a whole bunch of NTP servers out on the internet using the exact same address, but based on routers that are out there, they're going to forward you to the closest NTP server that's using that address. And if that one fails, well, then you'll be able to go to the next one, and then the next one if it fails, and then the next one. So always giving you access to the closest device that is offering the exact same service. So what does that give you? It gives you high availability, gives you redundancy for those services. So you might have data centers that are distributed throughout the world. Well, what do you want to do to get those customers of yours to the closest data center or to the closest e-commerce site? When you go to Google's website, do you want to go to Google's website in Australia? Well, yeah, if you're in Australia. But if you're in North America, you want to go to Google's website hosted in North America. Why? Because you'll have a faster response time. Likewise, with video sharing services in the world or streaming video services in the world, you want to go to the one that's closest to you. There's multiple servers, multiple data centers throughout the world, but you want to go to the closest one. Now, what if the connection to the closest one fails? Well, then you want to automatically end up going to the next closest one. That's what Anycasting is all about. That's what it is all about. So we have unicast, multicast, Anycast. Broadcast doesn't exist anymore.